You may have come across plenty of projects where autonomous agents are integrated into computers. Often, these agents are equipped with limited tools, restricting them to interfacing with your emails, Excel sheets, or a code base. But what if we gave these agents with tools to interact with the real world in the form of robots? Inspired by this idea, we embarked on a mission to embed an autonomous agent into one of the most prevalent commercial robots, drones, and we decided to call it Drona, short for drone agent, and also inspired by the most intelligent teacher in Indian mythology, Dronacharya.
On a basic level, Drona is a drone control software that replaces keyboards and gaming joysticks with natural language commands. More ambitiously, it introduces a pivotal new component to be integrated in every robot, an emotional brain enabling it to interpret and even empathize with the user based on conversation. We'd like to highlight Drona's utility in two domains: agriculture and disaster relief. For the farmer, Drona means convenience. Drones can be directed to monitor crop health, pest infestations, or irrigation levels using simple native language commands. It is as easy as chatting with a friend. In disaster relief, time is of the essence. Through Drona, relief workers can promptly deploy drones, making them search inaccessible areas, deliver vital supplies, or establish communication. With multilingual support, on-the-ground collaboration becomes easy irrespective of geography.
Drona is built on ROS2, which is the most widely used robotic software framework. We used a simulated drone on gazebo simulation, which will work equally well in a real drone. We use LangChain for providing drone-specific tools to a GPT-4 LLM to control the drone. The web app is built on top of Next.js and Tailwind CSS. We're also leveraging other third-party APIs to make the flow even more seamless.
Now let's see Drona in action. Hello everyone, this is a demo of the Drona project. On the left here, we have a simulation of a drone. This is running in a program called Gazebo. On the right here, we have a web application where we can enter instructions to control the drone. And on the left below here, we have a terminal running where we can see the chain of thought of the drone as we instruct it to perform actions. Alright, so the first command we can give the drone would be to take off and maybe go left for, let's say, 3 meters at 0.4 meters per second. So as we can see, the command has been given to the drone and the agent execution is beginning. And there's actions and observations are running. And as you can see here, you have, the execution has begun, so the drone takes off and it's going left for, let's say, 3 meters. And that's it. Now I can also tell the drone to execute actions in another language. For example, we can use German from here, so that's convenient. And send this command, and essentially this command is telling the drone to go forward for 1 meter at 0.5 meters per second. So let's see, the drone is translating the command and it's executing. And so it started. So it's going forward for 1 meter at 0.5 meters per second. Yeah, so this is essentially 1 meter, this was 3 meters. Now, what if I were to tell the drone to do something unsafe, which would damage other people around the drone? So what if I tell it to go crash into the building? So the command is sent, and while it does, it checks. Okay, it says I cannot execute the command due to safety concerns. So as you can see, you cannot just tell the drone to do anything. It has its own agent that has ethical and safety guidelines which it will follow and not perform anything that the user is intending to if it crosses those guidelines. So this is a demonstration of a real life use case of Drona, which in this case is a farm. So as we can see on the left here in the simulation, we have a farm setup. We can see like a cornfield, then we have a field of trees, and we have a farmhouse, a car, and such. So let's ask the drone to go to the farm garden. And let's see it. So the first thing it does is it gets the farm garden location, and then it gets its own location to figure out where it has to exactly go. And it completes its movements. As you can see, it's moving to the cornfield. And let me just refresh the page here. So as you can see, the live camera feed of the drone is being registered on the web application. And as you can see, the drone went back 10 meters and then it goes to the right to the cornfield. So the use of drones can be very beneficial in farms, specifically in the case of inspecting crops or spraying pesticides, and it can become very, very easy with a tool such as Drona, where you can just ask the drone to inspect the field based on just natural language.
We are a team of 4 driven to build innovative solutions that bridge the gap between bleeding edge technology and real world applications. Feel free to check out our GitHub repo. Thanks for watching.